7. So for those who are unaware, this is the first meeting of the freshly formed rural working group. Just very quickly going through these slides again, please try and turn your video off to save on bandwidth. Please mute your microphone so we don't have terrible echo effects. As I've just said, please only use the WebEx chat to enter and leave the queue to speak. It makes things much easier for us. I'm watching Jabber at the moment, and I'm sure other people are on Jabber for actual comments for those who are struggling with audio or are feeling that they are getting drowned out or for whatever reason. Also, we have an Etherpad up and running, which initially we will be filling with names and affiliations, acting as a blue sheet. Once the session starts, I'll be requesting a minute taker, and I've mentioned Jabber already. As this is an IETF meeting, virtual or not, it is run under the IETF Note Well. These slides are available in the meeting material, so if you're not familiar with the Note Well, A, here is a copy, B, you can find it through your standard IETF documents and also the copies of these slides, which are available across the meeting materials for this meeting. I'm not going to go into this in great depth. This is the second part of the Note Well. If you have any questions, reach out and people can put you in touch with people who can answer your questions about the Note Well. So slightly covered this, but admin information, virtual blue sheet, we need a minute taker. Is anyone willing to volunteer to take some minutes? If not, can you all please find a chance? Etherpad is a collaborative environment. Anyone typing is gratefully received. So please help keep the minutes up to date. You've got the WebEx because you're listening to me or you're staring blankly at your screen. I've mentioned Jabber, mailing list, raw.ietf.org. You should know how it works by now. Thank you for those of you who have been quietly messaging me saying they can take some minutes passed on. In particular, that would be very helpful. And the meeting materials are on the data tracker. I'm reading the slide out, which is a bit boring. So I'll tell you what, I'll hand over to Eve at this point because otherwise it's just me talking and I'm far less interesting.
Oh, but you're going to continue to do the slides, right?
Yeah, I'm happy to keep wheeling the slides if that's fine, unless you want to try your hand at them. I've got them all prepped, so. Nope,
not at all. That was the recommendation from those who are running these sessions, that we just drive the slides from one location. So basically, as you can see, we've got all of the usual administrivia. We're at the point in our agenda where it's agenda bashing. As you've seen on the mailing list, we're largely going to be focusing on several of the drafts and updates to them. But first, we will talk briefly about the charter and milestones and raise some questions for all of those presenters and authors, and then head into a discussion session. And thank you all for basically weathering this virtual meeting because, you know, the zombie apocalypse is sort of happening as we speak. Oops, but we're seeing all kinds of stuff on your screen. Rick, up, there you go. So when you, okay, perfect. But welcome to those of you who may not have been to any of these sessions now. They began life, I would go to the next slide. The very first of the raw sessions happened back in IETF 104. And a big thank you and shout out to all of those people who organized those meetings, beginning with the BOF and then finally the charter getting ratified about a month ago, and all of the people who were co-chairs for these sessions as it evolved into the meeting today. I will tell you that, you know, I'm also thankful for being invited to participate in this working group as a co-chair. You may not know me. I went to my first IETF 23 in 1992, In a previous life, I founded and co-chaired the M-Music Working Group and have worked on SIP and RTP and have an ongoing interest in audio and video on the internet. But in a more recent capacity, I co-chair the Computing in the Network Research Group, and I'm part of the IoT Directorate. And my interest here is trying to see how basically the quality of service parameters or profile or metrics can be comprehended all the way from the application layer down to the hardware. And so, of course, RAW has a role to play there, an important role to play there. What is RAW? The motivation for RAW is that it really is a sister or companion working group to the deterministic networking working group. And the focus there obviously is on deterministic networks, but in the real world, determinism is something that is probabilistic. It's something that we'd like to be predictable, and that translates into how well the network is faring with regards to reliability and availability. And when DetNet was first initiated, there were several use cases that were not originally covered in its charter, particularly those around wireless. Some of those are use cases around aeronautical data communications, industrial or manufacturing, pro audio and video, gaming, edge robotics. But there are also use cases that were not necessarily covered in the MANET working group, the Mobile Ad Hoc Networking Working Group, that also fell within, which are a gap of sorts. So the problem statement here is, of course, that it's difficult to achieve determinism in networks and wired networks, and even more so in wireless. Some of the properties that are affiliated with determinism are low packet error rate, bounded consecutive losses, and most notably, bounded latency. And so you can think of RAW as extending the DetNet working group concepts, and as a first approach to that extension is to really look at and examine wireless technologies that can be scheduled, and a variety of other techniques in the frequency, time, and spatial domain that will help us with redundancy and so forth. And we want to be supporting both deterministic traffic as well as best effort traffic over these links. Next slide. And so therefore, the working group has a focus initially on 4 very specific technologies. The 802.15.4 time-slotted channel hopping technology, otherwise known as TISH or 6-TISH inside of the IETF. 802.11ax and BE, which is Wi-Fi. And in the aeronautical space, there's the LDAX specification, which you'll hear more about today. And finally, the emerging 3GPP 5G URLLC, which stands for ultra reliable low latency communication. So those are at least the first 4 technologies of focus. Clearly, RAW needs to coordinate with other working groups, most notably DetNet and MANET, but there are several others. And we can't do this alone. This is really a partnership with the layers around us, both above and below. And so we anticipate coordinating with other standards bodies like 3GPP, IEEE, and of course the aeronautical industry. For now, the focus is fairly short in terms of the life of a working group, 12 to 18 months, but of course that's just this initial phase and this initial charter. Most of our RFCs for now will be informational, but all of those sorts of decisions can be revisited as we discuss what should be in scope and what is our relationship to these other sister working groups. You can advance. For those of you who may not have been on the DetNet page, these are the milestones that were captured when the working group was blessed. as a working group. And so the milestones begin with really use cases that are articulated in this wireless deterministic ROM, and use case driven requirements that go along with that. Ultimately, we're hoping that all of that will inform an architecture or framework aspects, and that by the end of the year to have an evaluation of the existing IETF technologies, and most importantly, a gap analysis. And what I've cited here in terms of the, what I've highlighted or boldified here in the text are at least the working group adopting those documents, and a little further out, you can see the submission of more mature documents to the IESG to have them adopted as RFCs. Next slide. Back to you, Rick.
Okay, so one of the things, obviously the agenda for the rest of this session is presentations from one of the members of the author teams of various groups who have put together some drafts concerning use cases, requirements, looking at some of the technologies that you just covered. So one of the questions I wanted to really, I wanted people to have a set of questions in their mind, A, as they presented, and B, as they listen to the presentations, which is for a set of questions for the document authors. Are you asking for working group adoption for your draft, or are you just presenting something that you think is of interest, but you don't really feel that you can work on it further or whatever? If you are asking for working group adoption, I'm not that familiar with the background of some of you, and I'm not sure what familiarity you have with what working group adoption means. And as chairs, Eve and I are here to help you understand that, and we can have either online or offline discussion about what working group adoption means. Part of working group adoption means continuing to work on the draft after adoption, and those of us who've written drafts and gotten through to RFC status will all say it starts off as great fun and very exciting, and the last 25% is painful. And you have to understand that if you're going to keep working on these drafts, there is a little bit of commitment of time and effort. But equally, that time and effort is also required from the working group members. So if the author puts forward, or the author team says, yes, we'd really like this working group draft adopted, the working group, who is all of you lot, need to make an assessment yourselves, which is, do we think the draft that is being proposed is relevant to the working group? Is it within the charter as it currently stands? And obviously the chairs have a little bit of influence there, but our role is to make sure the group works on things in the charter. And the third is I think the most important point, which is, if this document is if a document is adopted by the working group, is there willingness within the working group to help work on it, to do the reviews, to read the comments, to send in the comments, and really help these documents get sorted? Because as Eve pointed out, the raw working group is chartered to be short-lived and then either recharter or disappear, depending on what we manage to do. So if we take 5 or 6 documents, particularly use cases and requirements documents, we need to make sure we get them reviewed, commented, in good shape, finished off, and up to the ISG and into that pipeline towards 48 and out to RFC promptly. And that relies on the rest of the working group doing the work as well. So that's just something to consider while people are going through the drafts we've got to present. So, and now it's the cue for the actual drafts. So excuse me one moment while I flip screens. Work out who is up first. I believe
the first one is the use cases. Yes.
It is. It is. Yeah, I got it. Hopefully I have these all in the right order, but I have not moved the chat window over the full screen button. There we go. Carlos, are you available? Do you?
Yes.
I will
Can
mute
you hear me
myself.
well?
Yes, I can hear you. I'll mute myself. If you say next slide, I'll try my best to find the next slide.
Okay, thank you very much, Rick. So, hi everybody. This is Carlos Bernardos from UCCM. I'm presenting our draft on use cases on behalf of the whole team of authors. This is version number 3 of this draft, although we had also some previous versions with different names as the raw working group name evolved. We will also change the name of the draft. Next, please. So basically, the draft as of today documents 7 use cases that we found interest and that we found contributors providing input for those use cases. And I want to thank you very much all the people contributing to the different use cases. For each of the use cases in the draft, basically we follow on a structure where we document briefly the use case. So we explain a bit, describe a bit the use case. Then we go a bit into the specifics of the use case in the context of RAW. We also try to justify, although in most of the cases it's pretty obvious, the need for wireless in the context of those use cases. And then we go into the actual requirements for RAW. Basically, we try to identify from the description of the use case and the specifics which are the distinguishing requirements for RAW. So in this presentation, I don't want to consume all the time. I think it's best to present the idea of the draft, and I will use a couple of examples of use cases in the draft. There are no special reason for choosing these 2 ones that I'm going to talk a bit about later, but just to present examples. So as of today, we have the aeronautical communications. That was actually the latest addition, although it's the first one in the list. Then the amusement parks, the wireless for industrial applications that I will explain a bit later, pro audio and video, wireless gaming that I also explain a bit today, UAV platooning and control, and edge robotics control. This is the set of use cases that we think are relevant as of today, but this doesn't mean that we don't want to add more if people think so and people also commit to provide some input. Next slide, please. So let's start with the first one, the wireless for industrial applications. So this is just a picture. I will not go into all the details, but this is an exemplary picture of what we mean by this use case. Basically, this use case represents what we may have in a factory today, where we have different machines with different sensors and different actuators that are controlled with a programmable logic controller. And we have some communication between this PLC, this programmable logic controller, and the actual actuators based on the input that the different sensors provide. And all these different elements may be connected by a different subset of technologies, wired and wireless technologies. Here we have some examples with SIFTs, Wi-Fi, Ethernet, and different heterogeneous technologies. Next slide, please. So what are the specifics of this example of use case, the wireless for industrial applications? So one I already mentioned, we have heterogeneous technologies, mostly wireless, and this is actually going more and more into the wireless flavor, let's say, because of the technology's evolution and also the different requirements of the industry 4.0. We have also multiple simultaneous links that may be used. Why? Well, first, to provide more reliability. So this is one of the main reasons for providing simultaneous links. We may have on each of the different links that may be involved variable link conditions, even in scenarios where we don't have actual physical mobility of devices or very low mobility, but because of the nature of wireless and the environment and the conditions may vary, and we need to take that into consideration. And also we may have different needs in the sense that we may have different traffic types coexisting in the same environment. One simple example is control loops for the programmability that I mentioned before, where we have reliability and latency typically as key constraints or key requirements. But at the same time, we may have monitoring and diagnostics traffic that is closer to BSF or kind of traffic, but is coexisting with the other one, and we need to ensure that both traffics can actually coexist. Next slide, please. So what are some of the requirements that for this use case, from this use case for RAW? Well, one is that the solutions may be should be backwards compatible in the sense that we should be able to transport both the regular traffic, like for example for the diagnostics and the monitoring, with also coexisting with the flows that require predictable behavior, like the control loops that I mentioned before. And another key characteristic that is present in these use cases that we should support multiple wireless access technologies working simultaneously. And well, this is one example in the slides. TSH with backbone segments using, for example, Wi-Fi. So these are two key characteristics of this specific use case. Next slide, please. Then we can change to a different use case, just for the sake, again, of providing a different example, but it's not for any particular reason. We could have chosen another use case, which is wireless gaming. So in the gaming industry, we may basically identify three different scenarios that involve somehow wireless. One is the real-time mobile gaming, where we have different players connected and playing in real time, where the characteristics in terms of showing the same information at the same time to all the players is critical. That may involve wireless or may not be involved wireless, but typically this, since it's mobile, involves wireless connectivity. Another kind of family or category is wireless console gaming, in which we have the connectivity from the device that is used from the player to the actual computing element that may connect to something else, or being local gaming, but still connected wirelessly from the console to the device that is used by the player. And this requires typically very low latency and jitter for many games. And then we have the cloud gaming that typically requires low latency and may involve or may not wireless connectivity, although in many cases it involves also wireless connectivity. So we focus on the wireless console gaming, which is probably the one that's more representative for RAW. Next slide, please. We can list here, and I will not go into the actual details. These are taken from an IEEE reference, if I'm not mistaken. Some actual requirements in terms of numbers of what they mean by latency and reliability and all these kind of things requirements. So they mention intra-BSS latency less than 5 milliseconds to provide the required gaming experience. Jitter variance less than 2 milliseconds, and packet loss less than 0.1%. So these are just actual examples of real numbers that they mention in this reference. Next slide, please. If we go now into the requirements for RAW, taking into consideration these requirements and the description of the use case, well, basically we have a set of requirements listed in the draft. We have the need for time-sensitive networking extensions, such as time-aware shaping and redundancy. So these three extensions that can be explored to address congestion and reliability problems that are present in this type of networks. We may have the need for priority tagging to identify different streams, which is a basic tool to provide better QoS for time-sensitive traffic. And we need to identify what are the packets that require this specific treatment, and separate or isolate those from other type of traffic like best effort. We may need to have also time-aware shaping, as defined in AO2.1QBD, that allows to do some scheduling for the traffic. We may have different dual or multiple links used simultaneously to improve the latency, the stability or the reliability. And we may also need to make use of different admission control techniques to be sure that we can manage congestion and provide the required management or the required treatment to the most critical traffic. So these are examples of requirements that we have from that specific use case. And if we go to the next slide, please. This should be the last one. So in terms of summary, so as I mentioned at the beginning, this draft is currently documenting 7 use cases with input from different people. This doesn't mean that we we don't think there may be other use cases, and we are actually welcoming any input from other communities that we may have missed, like maybe a smart grid. I think that there are some potential use cases there. So in terms of next steps, it's a question for people interested in working into this. Do you think that we need to document additional use cases relevant for raw? We should be continue on the characterization of the use cases in terms of requirements, and also maybe in terms of the way we present the requirements in the draft. This is a structure that we follow from the beginning, but people might think that there is a better structure to follow. And then the last question related to what the chairs presented at the beginning. Well, we want to make the question about whether you think this is a good baseline that could be used as for the document, the milestone that we have on use cases. So this is a question open for you guys. We trying to answer the questions that you make. We understand what that means if the document is adopted as working group document, and I think that's it.
Okay, Carlos, we've got Todos Eckhart in the queue. So go ahead, Todos.
Very nice document. So maybe one comment. So slide 8, I don't really think that those are really, requirements. This seems more like, these seem to be possible technologies that can help to solve one or the other part of the problem space. So maybe rethink how this could be characterized. Certainly think it would be good to do more than just requirements, like, comparing, analyzing those different methods. I think there are a lot more to solve these, the requirements that were listed in before, but maybe not calling them requirements.
Okay, that's a good point. Yes, that's a bit more into, problem and space in terms of technology that can be used to meet the requirements that the use case poses. Yes.
We have in one of the multicast groups, I think MBOND or PIM, sorry, I always mix that up, a document about multicast and wireless, also kind of, solution approaches were compared, but whether that would be fit into the scope of your document to analyze these things, I'm not sure.
Todos, could you try and find what that document was and perhaps send a link to the mailing list?
Yeah, will do.
Thank you. Go ahead, Carsten.
Carsten, you're on mute.
Yes, I'm on mute because the user interface has this nice feature that when you activate the window, the mute button jumps from one side to the other side. So you press some other button and you need to clean up that button press and then find the real mute button, and then you are unmuted. Okay, my question is, you had this requirement that this needs to work over paths with multiple wireless links. And I'm trying to understand whether you are saying this needs to work over links that constitute paths that then are used by an application, or are you trying to say the mechanism actually needs to be able to work across multiple links so that the mechanism actually spans paths that use multiple links?
So basically some use cases require paths to be composed of or traverse, or the path might be composed of different links of different technologies. And also, if we think of a link, let's say like what we have between two nodes, there may be also the case that for some specific of these links, there may be multiple actual physical links involved by the technology used. So this is what we mean by multiple heterogeneous links. So we are talking about multi-hop networks that may be using multiple links through the path, or we may have scenarios in which we have one single hop that is connected by two different links. Like you can use one or the other or both at the same time. I don't know if this answers your question.
Yeah, the second part was the interesting part. So you are thinking about combining different links, so you actually do need something that works across multiple links.
Yeah.
Thanks.
Go ahead, Bob. You're in the queue.
Thank you. Can you hear me okay?
Yes.
Loud and clear.
So, I mean, this is new to me. I just joined because I wanted to watch one of the sessions. I'm not sure I understand the need for this for gaming. It seems like there's lots and lots of interactive gaming going on today, the mix of wired and wireless. So I'm not sure I followed why this is an important use case here. I mean, is
Well,
there really such a big need that it needs something new?
yeah, this is this input. I don't remember exactly who provided that input, but this came from somebody in the industry, and he or she, I don't remember, sorry about that, pointed out that need. So I mean, I'm not the one proposing as individual that use case, but from what I understood from the people that provided that, yes, there seems to be that there is a need for something new. I can try to remember who was the person and maybe post that question on the mailing list as well, so we can have a more detailed answer, but this is my understanding.
Okay, so it sounds like the use requirement isn't that strong.
Bob, it's Rick Taylor here. Just to answer this use case draft covers. I brought up one of the starting slides. It's not just about wireless gaming, and the raw working group is not just about wireless gaming. I think it's one of those from left field use cases that could be applicable and makes it a good subject to discuss. But there are a lot of other use cases. So we're not looking specifically at wireless gaming use cases. It's just an example. Go ahead, Eve. I'll shut up for a moment.
Oh, no. I was going to also extend the idea that gaming is encompassing some of the sort of more immersive experiences that are going on, where you might have multiple streams coming from different cameras and they need to be stitched together to form something immersive in 360 degrees. And so those kinds of stitching algorithms may require more precision, both for the recreation of more realistic visuals as well as audio. And so that might be another way to look at the wireless gaming, that it's not just interaction with consoles, but this other arena, although maybe that requires its own bullet here. I don't know. I wasn't participating when this use case draft originally was drafted, but I do think that there's that adjacency with AR, VR.
Okay, so next up in the queue is, I only have, it says Kuhn. I'm guessing. Go ahead.
You may be on mute, Kuhn.
He is on mute. We can't hear you, I'm afraid. He's left the queue. Oh. Right, I've just caught sight of the time. I think we should probably wrap up this presentation. Thank you very much, Carlos. This is where I'm now looking at.
Okay, I'm helping you. LDAX is the next
yeah,
presentation up.
My question is whether, so the team behind the use cases draft at the last slide said they're asking for working group adoption. So I'll make a note of that, and at the end of the session, if people can, chairs can unmute speakers as well. That's useful. I think what we'll do, we'll ask for working group adoption on the mailing list after the session. That is
right. No humming. Humming would be too complicated.
On the list after the session, I will make a note to get that out. Right. Without any further ado, LDAX. LDAX?
Yes.
Oh, that's right. It's PowerPoint. Oh, I've got to work out how to share a different application. Share content, PowerPoint. Can you see that?
Yes.
Excellent. I'll shut up. So, Niels, if you're there, the microphone is all yours.
Hi there. Can you hear me okay?
Yes, we can.
Yes.
Perfect. Yes, there we go. There we go. Nice.
Thank you.
Yeah. Thank you for joining us today. I'm going to present one of the use cases for aeronautical digital communications. In that case, the L-band Digital Aeronautical Communication System called LDEX, and it's now the second version of the draft, so it's a 1. Next slide, please. Yeah, so I think we all covered the node well. Perfect, there we go. So where does LDEX come from, and some of the history also. We listed most of that in the use case draft. So as you can see, what we've listed here is that currently civil air traffic is growing. Also, we have new entrants such as UAVs, so unmanned aeronautical vehicles, and all of those need to be managed. So currently, air traffic is expected to double by 2040 compared to 2018. However, that's debatable with Corona right now, but it's a different matter. I will not go into detail of that. However, most aircraft still use analog voice communications today, and this creates a bottleneck for growth. That means if you're in a holding pattern, it might just be that all the frequencies are already covered, so no air traffic controller has the time or possibility to actually talk, and so you're in a holding pattern. This is all because of analog voice communication. And it is foreseen that there's a transition, also digitalization going on in that area, to an IPv6 aeronautical data link, which is called the FCI, the Future Communication Infrastructure. And the Future Communication Infrastructure covers several links. So one of those are LDEX, which I'm presenting now. Aeromex, it's already a system in use, mostly for airport communication and in the terminal maneuvering area, and obviously SATCOM for Oceanic Pole and remote, so OPR regions. And it should support quality of service, diversity, mobility, and it is a multi-link concept. So for instance, an ANSP, so Aeronautical Network Service Provider, wants to send some message. It doesn't matter which link that message takes. In the end, it just needs to reach the end destination within a given time and with a certain reliability. So the relevance for RAW here is reliability and availability shall be achieved using a multi-link concept. And the multi-link can also be seen on the right-hand side with this little drawing. So we have several aircraft in the air. There will be an LDEX air-to-air communication data link. There will be an LDEX air-to-ground communication data link that I'm talking about right now. As we said, satellite and Aeromex for airport-based communication. Next slide, please. Yeah, so this is the current version of the draft, 1. And we're basically introducing at the moment what LDEX is, why we think RAW is the right place to be with LDEX, and explain the initial ideas about the IPv6 via LDEX adaptation. Next slide, please. You can see the table of contents. That was a little bit too quick. Thank you. Oh.
Sorry, my bad.
That's all right. No. There we go. Perfect. So the table of contents, since the version 0.0, we added information about mainly about the reliability and availability section, added some important information about the entity services, so everything in section 6 got updated, and also the mobility increment deployment was very important, and I'm going to dive into that in more detail soon. Next slide now, please. Perfect. So here, clarification of IPv6 network for the future communication infrastructures and the provenance and documents. As we speak currently, there's no standard document in the ICAO frame. So ICAO is the International Civil Aviation Organization that basically writes the standards for all international civil avionics activities. And that means that there is this opportunity as we speak to define rules and subsets of rules for an IPv6 network that's covering all the different data links and also how and what data is going to travel over that. Speaking about the data content, so what data is actually traveling there on the link, we're talking about aeronautical traffic control, that's ATC data. We're talking about aeronautical operational control, that's AOC data, and that's all safety relevant data. That means we have this high safety requirement on the data link. That means it needs to reach the end destination with a certain amount of probability, obviously, and also within certain latency, which is very important. Then in the second point here, we updated the LDEX medium access part. That's basically just for information how it's implemented there. Then the LDEX mobility and the LDEX incremental deployment is important. Why? Because as we speak, there was a flight campaign going on a year back where several of German institutions, research institutions, and the industry were testing LDEX already in flight trials and confirmed that it's working as it's supposed to work. So that was the very first maiden flight of LDEX, 25th of March 2019. And now the question is, how is this going to be implemented? And we also added here in the incremental deployment section some information about that. And as I mentioned before, the protocol stack got, was explained more in depth. Next slide, please. Yeah, so here we're talking about the protocol stack and the services. Basically, as you can see, we have the subnetwork link layer from the top. That's the LDEX subnet management entity, the LME. That's basically responsible for managing if there's a new entity coming in, like an aircraft is coming in, talking to a ground station. Then the LDEX management entity is responsible for managing resources and so on. Then we have the subnetwork protocol, the SNP. That's basically the translation area from IPv6 format into LDEX specifically, a data format. And also this is where user plane cryptography is added, such as encryption and message authentication codes attached to the end of the message. We have the data link layer. There, the resource and request reservation is handled via the MAC layer. It's priority aware, and it's reliable for automatic retransmission. So we have an acknowledged data transmission here. And on the physical layer, we have OFDMA on 2 FDD radio channels. And this is now important to note. It's 500 kilohertz each and hardened against aeronautical interference. Why is that important? Because we're talking about the L-band. The L-band is the safe space for aeronautical communication, so to speak. So outside of that L-band, no safety relevant data is actually allowed to be sent. And the problem with the L-band is it's already full, or almost full. For instance, there's a service called the distance measuring equipment, DME, that's sending with loud radio bursts, and LDEX had to fit in. So we're talking about an inlay solution here for a robust data link between DME bursts, and the data channel size got reduced to 500 kilohertz each. Next slide, please. So here you can see the MAC layer design frame structure. We have a super frame that's 240 milliseconds, and we have 2 directions that we're sending. So from the ground station to the aircraft, that's the forward link. From the aircraft back to the ground station is the reverse link. And basically, ground station is sending data all the time, so continuously broadcasting, and an aircraft needs to request resources in order to send something. Here we see the BCCH, that's the broadcast control channel. Here beacons are sent from ground stations, basically announcing their existence. And here we have the random access channel at the beginning of each superframe from the aircraft, basically requesting access to an LDEX cell. Then a superframe carries 4 multiframes. Each multiframe in the forward link is 1 data channel, so that's user data, and 1 common control channel, basically granting resources to an aircraft. And in the reverse link, you can see we have 1 dedicated control channel that's basically aircraft asking for resources, and a data channel for user data. That's what you can see here. Next slide, please. So the mobility support, now we have abbreviations again. It is foreseen that a ground station controller, a GSC, controls several ground stations, and several aircraft connect to 1 ground station. So 512 aircraft can connect to 1 ground station, and several ground stations to 1 ground station controller. So that means that the mobility service manages in the ground station controller and in the LDEX management entity, and that is cell entry, cell exit, and handover. it's important to note that that LDAC supports break before make or make before break. That means if a ground station area, so LDAC is a cellular system, is left and an aircraft enters the area of another ground station, but both ground stations are connected to the same ground station controller, then we can talk about seamless handover. So basically, it just switches from one controlled area from one ground station to the next. And then the development, as I said earlier, is envisioned in this incremental manner. That means right now all the physical layer details are done, then the MAC layer is done, and SMP is done. Another question is how do we get the ANSP data in the IPv6 format now via multiple link environment, for instance, over LDAC safely to the plane. And yeah, the scalability of LDAC, because it's a cellular system, basically means that if you have high load in one area, that you can implement it already there and then increment it in future areas where it needs to be implemented. Another aeronautical communication system that's already done this approach is Aeromax. That's already deployed in around 46 airports around the world, mostly in China as we speak, and it's using the same development and manner. Next slide, please. So here's a summary of what LDAC is going to bring. As we're speaking, all safety relevant data for a flight is either transferred via a voice link, so technology invented basically in the 1940s, or via ACARS or ATN, or via VDL Mode 2. That's another proprietary data link that's able to handle 35 kilobits of data, and so comparatively speaking, LDAC provides high data rates like a 4G like data link. And the reason why we're talking 2 megabits here is basically of the slim 500 kilohertz channel size. Then it's designed for long-range communication, so 400 kilometers, about that in a regulated aeronautical spectrum, 1 gigahertz. It's designed with safety of life use cases, so we need reliability, predictability, and so on. And as I said earlier, with this DME bursts, basically jamming the L-band, this is the only suitable solution for this regulated spectrum to provide a digital data link here. Then it's designed with a multi-link IPv6 concept as a network layer, and it's now this transition, that's the big thing happening here, from ACARS and OSI to the IP network protocols. Next slide, please. Yeah, that's also my last slide. So that's the relevance for RAW. Why we think LDAC is a benefit here for RAW is basically because here we have several questions that RAW tackles to answer. For instance, we have this multi-hop, multi-link system with a determined time, so latency, where when packets need to finally reach its end destinations. And there's currently going on this open standard at ICAO, so there are standards about LDAC in ICAO, and the work about how an IPv6 network will look like in the future, covering all these links and the data services, that's currently an open discussion, and we thought it is very valuable to get the IETF input here. Also, we were talking about gaming before. Here we're talking about a very critical, time-critical information. For instance, if you have a wake event or something like that, where 2 aircraft approach each other too closely, you need to react fast, obviously. So it needs to be this reliability and predictability data link that I think we're also looking. So yeah, that's all from me. Thank you very much for your attention. If you have any questions, feel free to ask. Thank you.
Thank you very much. Go on, Eve. It's all yours.
Oh, no, I was just going to give Stuart a card. Looks like he's in the queue. So, Stuart, go ahead. You have to unmute.
Am I on?
We can hear you.
Okay, background noise is really bad, so I'll speak fast and then get off. I'm just wondering how, if at all, does this relate to the ICAO's Aviation Trust Framework or its Global Resilient Aviation Interoperable Network, GRAIN, and I'm going to just post into Jabber a few lines of text from a presentation from Sao da Silva on that.
Thanks, Stuart. Thomas, go ahead.
That's Thomas. Maybe I can provide some, well, I'm one of the co-authors of this draft, so I can maybe offer some explanation to Stuart's question here. I have the link to the GRAIN website open myself in the browser, and as far as I can see, this is an FAA program, so it's at least to the best of my knowledge, not directly linked to what we're doing at ICAO. It's certainly an interesting idea, but the idea behind GRAIN is basically to use commercial off-the-shelf networks for air traffic control, and that's, let's say, an idea that is heavily debated. As of now, there are no standards at ICAO that would allow to do that legally. The only thing that is currently under development at ICAO is the development of dedicated links for aeronautics, like the LX, like Aeromax, like different flavors of SATCOM. That's the only thing that is actually in the works of becoming standardized. Everything else is a little bit farther in the future as of now.
Thanks, Thomas. Stuart says thanks on Jabber, so yeah, I think that gave him the information he needed. So Eve, who's next? Because my screen is full of the previous slides.
Janos, speaking about 5G, the newest draft.
Okay, give me a second to just try and get out of. There we go. Goodbye. Janos, 5G. Can you see that? Let's go to start, because I was reading your slides earlier. There we go. How's that?
Looks good. Hi, Eve. Hi, Rick. Thank you very much.
No trouble.
So this is a contribution from a couple of colleagues and myself in order to provide some details on 5G and explain that 5G is reliable and available wireless technology. So a very good candidate for ROW and meets the requirements actually we've been hearing before. We will be giving together this presentation with my colleague Torsten Duda. He will be speaking the first half and I will be speaking the second half. So I will give the word over to Torsten.
Okay, thank you very much. Can you hear me well?
Yes.
All right. Okay, so okay, good. So yeah, this presentation is about 5G as the technology to provide ultra-reliable wireless communication with low latency. And we can switch to the next slide then, please. So here we see the outline of the presentation. So we will start off with having a look at the different use cases in 5G, provide an overview about the 5G technology as such. Then have a look at the 5G NR, that's the radio interface, low latency features, going then to reliability features. Then Janos will take over with the multi-connectivity features, looking then also on how TSN can be integrated with 5G, how to combine 5G with DetNet eventually. And then we can switch to the next slide. So we saw already in the presentation earlier a couple of use cases that are addressed here and that require raw communication technology. Our focus here is on the industrial use cases. And what we can see here is a list of those. This list was developed or identified in the 5G ACIA. That's an industry consortium where actually OT players and IT players come together and discuss relevant use cases and solutions. So we see here, for example, some use cases from industrial automation, motion control, mobile robots, also process automation use cases. And their availability requirement is very tight. And the latencies that we are talking of, they are in the millisecond range here. and it's typically periodical traffic, so the latency requirement is then typically lower than 1 cycle time. Payload sizes are low, and yeah, that's how those use cases are characterized. So let's then have a look how 5G can address those use cases in the next slide. So 5G is actually quite a flexible technology, and the core use case is mobile broadband, but it's expanding into different use cases as well. So we have the massive machine type communication, so that's a huge number of sensors communicating. And then what we are looking into today is the ultra reliable and low latency communication, so URLLC. And this is all about providing a bounded low latency on the communication link. And this bounded low latency is then based on low latency provisioning as such, resource management, reliability features, and also time synchronization. And we can have a more detailed look at those features, and starting with the next slide. What we can also mention is that 5G and the radio access, so NR, is scheduled. So we have a centrally scheduled system here. Radio resources are in downlink and uplink provided by the GNOD, that's the base station, to the device, the UE, in order to fulfill the QoS requirements, the service flows of that UE, taking into account and also the propagation environment, for example, and so on. And we are talking here primarily about licensed spectrum, so resources assigned are then also guaranteed to be used by that assigned user. We have also admission control inbuilt. So when there are, for example, further users coming into a system that might destroy the QoS of existing users, we can not admit them to the system, basically, simply saying. Yeah, and these features are then all for quality of service assurance. There's a QoS framework throughout the 5G system where QoS flows are established, so in the core network and the radio network, so that we ensure the QoS requirements that we set up. That's, for example, the packet delay budget, priority among those flows, or a packet error rate requirement. And we can switch to the next slide, please. When it comes then to the low latency or the URLLC features that we have in NR, and those are, by the way, applicable both to IP traffic as well as Ethernet traffic. So there are both session types defined in the 5G system right from the start. So then, first thing to mention is the support for different OFDM numerologies. So we can scale up the subcarrier spacing. So when we do that, then we make the system more applicable to higher carrier bandwidth. So we have we can cover low band, mid band, and millimeter wave bands. And when we scale up this OFDM numerology, then we scale down the slot duration. So for the lowest S subcarrier spacing, so the numerology, we are talking about slot durations of 1 millisecond. That might be then applicable or beneficial in the low band, but in the millimeter wave, we would rather choose the 120 kilohertz there, and we would have 1/8 of this millisecond slot duration in that frequency range. Beside that, we can also go down in the latency by using mini slots. So we can subdivide also these slots into mini slots. So there are up to 7 mini slots are supported within one slot duration. So that's another degree of freedom here. Yeah, we have the centrally scheduled system. There's dynamic scheduling supported, where the device, the UE, needs to request resources from the GNOD, and the GNOD then at base station so assigns these resources then in the uplink to the uplink users. But that step induces a certain latency that can also be skipped by using pre-scheduling techniques. That's especially then beneficial for the periodical traffic that we would typically have in these industrial use cases. Preemption is supported as well. Maybe we have a long slot for a mobile broadband transmission, but that can be interrupted by a short URLC transmission that might be necessary at any point in time. Yeah, and the devices, the UEs, they are specified to use fast processing times for encoding, decoding of the data, and that enables then also a very fast retransmission scheme, a very fast HARC scheme. Yeah, there's also multiple control channel monitoring, which further improves this HARC scheme, basically. So these were the low latency features. On the next slide, then, we have here 3 features to provide reliability. So to basically bring the latency upper bound down. So first of all, we have possibility to schedule with very robust control and data channels. So extra robust modulation and coding schemes were specified. And we have also the channel state reporting so that the base station is actually able to choose the correct and appropriate modulation and coding scheme to provide the robustness via the link. There are multi-antenna techniques as well, so we can exploit the spatial diversity by using multiple antennas or multiple antenna elements at the transmitter and receiver side. And that can be even complemented by multi-connectivity, where we have these multiple antennas from different sites using different carriers. And with that being said, thank you, and I would hand over to Janos.
Thank you. And going to the next slide, please. So we heard about the need for multiple wireless channels in the previous presentations. And actually, 5G has multiple options, various options to provide such multi-connectivity. These are shown or summarized in this slide, the 3 variations. And the one to the left-hand side is the most robust. This is the dual UEs, meaning that we have 2 UEs, and these different UEs are connected to different G-node beads that are connected to different UPFs. So practically speaking, we have completely disjoint paths over the radio this way. And a bit less robust is then if one cannot afford or doesn't want to have 2 UEs, but only have a single UE, that single UE can connect to 2 G-node Bs, a master and a second G-node B, and have the rest of the communication path redundant. And the red boxes in these 2 cases show the packet replication and elimination and ordering functions defined by DetNet, and the frame replication and elimination function defined by TSN. So these are part of the device on the UE side, on the 5G side, and somewhere in the network on the other side, this is not, which is not shown on the figure. The 2GPP specification is written in a way that both techniques can be equally applied. So this is the way it has been written from day one. So in this sense, 5G is kind of ready for the service protection defined by DetNet. The third option on the screen for multi-connectivity is when we only have a single UE connected to a single G-node B, then we still have a choice or a possibility for multi-connectivity. We can have a PDCP duplication, so we can have 2 carriers between one UE and G-node B. Okay, so this was just a summary on the multi-connectivity. Please go to the next slide. Okay, this is a one-slider summary of 5G integration or for TSN or 5G features provided for TSN, common deployment with the TSN network. This has been added to release 16, the TSN part. But the Ethernet PDU session, which is the basic of this enhancements is already there from release 15. So the classic PDU session in 3GPP is IP, and Ethernet was added via 5G release 15. The key concept for the integration with TSN is that so the 5G system control plane and user plane are separate, and on the user plane the 5G appears as a virtual TSN bridge per UPF. So two virtual TSN bridges are shown in the picture. These are these orange bridges or boxes in the middle, which incorporate the Ethernet PDU sessions. So these two also show the redundancy aspect. And on the right-hand side, you see an industrial automation TSN network. So the main use case is industrial automation, which is supposed to be compliant to the IEC IEEE 60802 TSN profile for industrial automation. The goal is to be able to include 5G in such a deployment. Actually, the goals of this work and the requirements are met was listed in on slide 8 by Carlos. So all those requirements were in mind when this work has been done. For example, how to integrate with system deployment when the 802.1 QBV scheduled traffic, which was formerly called as time-aware shaper, is used. And for that, the key components are the so-called TSN translators. You see at the edges of the virtual bridges, these TTs. And a key part to be able to integrate is that between these TSN translators on the UE side and on the network side, a 5G can provide a deterministic latency. So this is achieved, for example, or can be achieved via hold and forward buffering techniques. And what we are talking about is 1 millisecond, for example. So that's the target. Having these deterministic Ethernet PDU sessions, we get the end-to-end Ethernet deployment which is needed for an industrial automation. And it is now an end-to-end picture on the reliability part, in this case, TSN reliability part, the FRARE, when the replication and the elimination points are on the end station, these orange boxes. And as I explained in the previous slide, we have the multi-connectivity within 5G. So we have end-to-end disjoint paths, even in the radio, for the reliability feature. Let's go to the control plane. Release 16 supports the SDN approach of TSN, and 5G control plane needs to interface with the SDN controller of the TSN network, which has two components, the network controller and the user controller. And one attribute communicated, for example, when this scheduled traffic integration is needed, the latency value provided by the 5G, and providing this value to the central network controller. The network controller can design the latency and the transmission gate operations throughout the entire network deployment in order to achieve the scheduled traffic operation. So why is it important in RAW and in IETF and in .NET? So if we go to the next slide, next slide just illustrates that as just one word on this, as in the left-hand side, as Torsten explained in the beginning, this is a high-level picture of the URLC feature summarized, and on the right-hand side, what we see is the very similar features provided by the wireline technologies, .NET and TSN, on .NET on layer 3, TSN on layer 2. We have the resource management aspect, the reliability, the low latency, And the TSN provides time sync. DetNet doesn't specify its own time sync, but leverages the time sync available by lower areas. Let's go to the next slide, please. And here comes why I was talking about the 5G TSN integration. In addition, to point out that actually 5G meets the requirements listed by Carlos on slide 8, is that when we started the work in the DetNet working group, we first had TSN in mind as the first layer 2 subnetwork technology candidate for DetNet. That was wireline, that was easier, but obviously more to come. For example, wireless subnet technologies. And we are just rechartering DetNet, for example, to enable that. So how that's item A, and item B and C kind of look forward a bit on, okay, how do we combine 5G with DetNet? On item B, you can see, and there are various options for 5G acting as a subnet for DetNet, subnetwork technology. There is IP video sessions by default. As Thorsten explained, the URLC features are applicable to the IP video sessions as well as for Ethernet and so on. And when the TSN integration and features may be handy are shown under item C, that actually there may be, for example, industrial automation deployments where kind of heterogeneous 5G TSN deployment is needed anyways, but hierarchy is also needed, so DetNet will be used as well. And this is one of the cases when this TSN integration feature can be used. Plus, the work we are doing in DetNet is as TSN as a subnet, or the interworking between interface between DetNet and TSN can be leveraged given the TSN supports provided by 5G. So this is just initial thoughts here on this slide. And the next slide is just a summary to conclude that 5G provides centrally controlled scheduled wireless segments with high reliability and availability, so it's a very good candidate for all. And there's dynamic scheduling, and pre-scheduling is also possible to make it faster and avoid scheduling delays. Getting the slot type of delays. Admission control ensures QoS, and 5G provides quite good QoS guarantees. There are several features that can be used and combined for ultra reliable and low latency deployments. And already there are support included for industrial IoT, for example, the integration with TSN. As I already hinted, DetNet was already in mind in some of these add-ons, for example, when it comes to reliability. This is it. Thank you for your attention, and we would be glad to have your questions.
Thank you very much, Janos. Anyone in the queue? Nope.
In the queue.
I have a point. So at the start, before we started hearing the presentations from the various draft authors, one of the questions I put to the working group is this are the drafts being presented in scope for the Charter of RAW? And me personally, I think this is the 5G information is incredibly interesting, and yes, it looks like it really does have a place to play with DetNet and the TSN work. Does it apply in RAW? I think is an open question, because I know some of the discussions at the BOFs and amongst people within the raw working group is about heterogeneous, unlike bearers, that kind of area. And from my feelings is that 5G is hugely capable as almost a giant transit system in its own right. And so I don't know, it's an open question, and I'm not sure we should get into it now because actually time is ticking on, but I think it might be something to pose on the list. The other question to the authors is, are you proposing this draft as a working group? Are you calling for working group adoption?
Actually, the idea is that there is the raw technologies draft, and I suppose that will be developed some way, and this could be rolled into a future version of that draft. I couldn't exactly figure out, given the milestones of the working group, where that draft goes, but that would be a place for it.
Okay, that's actually quite clear. So you're not quite sure. I think as part of the call for adoption, the working group can help work out how it fits and how it fits with the charter and how it goes forward. So that's fine. So quite happy to have that discussion.
We have several people in the queue, and
we do now.
We do now, and I'd like to keep the questions brief if we could, and put a stop at the end of after Lou. But who is T. Capella?
Tom Capella here.
Terrific, Tom. Go ahead with your question.
Hi, folks. One question that comes to my mind regarding TSN specifically applied to this new radio paradigm space, especially with multiple UE presence and multi-attach, call it, something of a modern distributed input-output spin that I'm hearing or taking from the presentation here. Two things come to mind there. What do we think about, how do we think about, or have you thought about how we might avoid deadlocks in the midst of both congestive failures end-to-end, before the user plane, of course, could see this, or transport could see this, between convergence issues and call it loss issues. What do we think about deadlocking there? And the reason I'm asking about this is because we've solved some similar problems in data center bridging and so-called lossless Ethernet approaches that attempt to push, flow control, if you will, to the edges as much as possible. And so in those scenarios, we find some challenging situations in which convergence is at odds with congestive and normal network management activities. So have you thought about that sort of aspect to this, and maybe how does some of that problem space apply here, if at all?
So it's when it comes to the lossless Ethernet part, the standard that is planned to be used is this IEEE 802.1cb frame replication and the elimination for reliability, which is a 1+1 protection, practically speaking, per packet, per frame level. And duplicate copies are sent on the disjoint paths, and they have a sequence number, and the redundant copies are just dropped. So there is no failover time or anything like that. It is really that protection scheme. When it comes to how to avoid congestion, this is part of the central nature of 5G to do that, like we avoid the admission control and so on and so forth. So when establishing video sessions and so on, this is avoided. When it comes to the wireline pipe, yes, that has to be designed in order to have zero congestion loss, and that's the job of TSN and the central network controller in the SDN approach.
Thank you. Yeah, certainly within this context here, the curiosity really is to me, it hinges on the vagaries and the mobility-induced variabilities of the channel conditions, especially in a multi-point or distributed multi-point network. So if we're extracting it to the level you're describing and going no further, certainly makes sense to me. But I would wonder about or invite the idea that if we had a really, call it high-level scale-out, call it asymptotic scale-out interest in one UE being contacted by multiple downlinks from multiple G-node Bs at one time or more, we would want to understand, what we think about how we deal with the fact that all the radio link state or channel state will be consequently highly variable, and how we avoid that potential to deadlock.
Yes, that definitely needs to be done. Yes.
Okay, let's take one more question, and then I'm going to, in the interest of time, ask that we hold the rest of the questions. Abdus Salam.
Yes, hello.
Hello.
Hi, do you hear me?
Yes.
Yes, my question is a little similar to the previous one. Is mainly I'm interested when I'm listening to any use case draft. What are the main challenges to this use case? So maybe there are a number of main challenges which can be, as this the technology can be used for our application for this case. So that's what's the main challenges.
So we have to select a use case, and let's select the industrial automation, because that's the main target, or that was mainly what I was talking about, not the gaming, but the industrial automation one. And actually, the two challenges is both the high availability or high reliability availability. So that's essential for industrial deployments. Like it is, some of these are safety critical, or human lives are there, or shutdown or breakdown of a factory for even for just minutes. We lose a lot of money. So the reliability aspects are very important, and I was talking about solution aspects, and as well as the control loops. The typical control loops are closed control loops with which are periodic CBR. So luckily quite predictable, but they have time requirements. So those time requirements have to be met. Otherwise, again, we may end up in a situation that some parts of the factory is shut down and so on and so forth. And so both the latency and the reliability are challenging, and actually release 16 went beyond release 15, even within 5G in both aspects, and providing better numbers.
Okay, so Florian, do you want to go ahead with your question?
Okay.
Sorry, Eve, I spoke all over.
No, I was just wondering, we're pretty far off of our schedule at this point.
Okay.
And so it's just a matter of whether we want to take all the questions now or defer them after the next set of presentations.
Let's defer them and let's get the presentations on target, because.
And we'll circle back.
Yeah, sorry guys, those who were standing in the queue. So
next,
that's my cue to find the right thing, isn't it? So it's Georgios next.
Hello, guys.
Stupid WebEx window. Yes, we can hear you, Georgios.
Lovely.
Can you see the slides? Good. Yes.
Yes. Thank you so much.
No trouble.
I hope you are doing fine, guys, with this situation. The coronavirus, by the way. Okay, so back to work. So this presentation is related with the Pareo functions. So we wrote this draft with Pascal and a few of my colleagues here at the EMT Atlantic. Can I have the next slide, please? So I will present three parts here. Will be the motivation, why we need the Pareo functions. Then I will detail each of these functions that consist of Pareo. And then if I have time, I would like to emphasize the importance of selecting the alternative parent when we are doing the multipath within the Pareo. So next slide, please. Yes, that's the motivation. Next, please. Thank you. So RAW aims for reliable communication. Then we aim for guaranteed maximum or bounded latency. And finally, we would like to have the low jitter performance, right? So these are the key objectives that we would like to have in RAW networks.
So to do so, I will present the Pareo functions. Next slide, please. Again, please. Okay. So with this example, I would like to present how Pareo works and what are the main functions. So considering this two-hop wireless topology, where S is the source, D is the destination, and then A and B are the relay devices. Next slide, please. First, we start with P, which stands for packet transmission. So in this case, I will have the main transmission from source S to its preferred parent, A. Now, here I would like to show you that on the right side, I have the topology, and the left side, I have at the same time, a typical schedule. In this case, it's an example of 15.4 technology, IEEE 802.15.4, but can be any topology that uses schedules for their transmission. So when S transmits the packet to A in this case, then in the schedule we have in time slot 1, which is the time axis X, and Y is the axis for the channel offsets, integer values that will be translated to radio frequencies. So here we have the first function, which is the actual transmission, and then next slide, please. So then we have A, which stands for the arc, then it's typical retransmission. Then if the first transmission is not successful, S will retry to send again the same packet to its preferred parent in the consecutive time slot 2. Then next slide, please. So once it does transmission and then retransmission, the arc part, then we are having the R function, which stands for replication. So in this case, S, as the source device, will replicate the same data packet to its alternative, what's called alternative parent. So then we have time slot 3, where S will send the data packet to B, which is the alternative parent in this simple example. Next slide, please. Then we have the fourth function, which is called overhearing. So we have the promiscuous overhearing. Now, considering that we have the wireless medium, which is broadcast by nature, then any neighbor of a transmitter may overhear this transmission. This function will allow us to increase the probability that the data packet will eventually arrive at the destination, which is D. Now, to show you the example in the next slide. So here, again, let's assume that S transmits data packet to its preferred parent, A. Then we have the alternative parent, which is B in this case, to overhear this transmission. Can be in both transmission, the first one, which is time slot 1, and the retransmission, the arc, vice versa. When S will replicate actually the packet towards B, so it will be the blue line towards B, then A may overhear as well this transmission. So in this, excuse me, thank you. So here I have A, when there is no parenthesis, is the actual transmission, while the B and A that you see within parentheses are the overhearing procedure. So you have one transmitter and potentially two devices may receive this transmission, but only one actually will acknowledge. So only the actual preferred destination, but the one that has the destination address will acknowledge the transmission. Next slide, please. Now the last function that we have in this Pareo toolset, it's called the elimination. So actually what happens here is that at the destination, once the receiver received already the first copy, it will discard the copies of the data packet which was previously received. So in this case, by time slot 4, both A and B already receive this data packet, and when they will forward this data packet to the common destination, which is D in this case, first will be from A to D, we have the transmission, and then we will have from B to D. The second copy, so the time slot 5, will be discarded, so D will not potentially forward further in the network in order to avoid potential traffic, additional traffic, unnecessary traffic in the network. So this is the fifth function, the elimination part. Next slide, please. Now, if I have a few minutes, I would like to emphasize a little bit the importance on how we are going to select this alternative parent. So this part, it is not yet written in the draft, so it will be food for thoughts to discuss in the mailing list whether it will be necessary or not to include it. So next slide, please. So the idea is that if we do not control how we are going to select this alternative parent to do the multipath and the parallel functions, then we may end up on certain level of network flooding. So I have the example on the next slide. So here on the left side, you may see the a little bit chaotic version of this multipath where we do not control how we select the alternative parent, while on the right side, we will have this, what we call the DNA pattern, where the two parallel paths from the source till the destination are close to each other until the end. And the interesting part here is that this DNA pattern will allow for an efficient operation of the overhearing procedure. Because if we split the two paths really far away from each other, then we may not have the operation function takes place. So this is the, yes, thank you. That was the example. And here I have another example that indicates a possible option to select an alternative parent. It will be as the one having a common ancestor with what we call default parent or preferred parent inside the network. I will give you a few examples. Next slide, please. So here I have 3 different examples. We call it strict, medium, soft. And the concept is where we have G as the source node that will send the packets towards the destination. So this is just sub network. So after A, B, C, we have continuation of the network, of course. So in red are the paths of the preferred network. Like G has a preferred parent D, and D has a preferred parent A, and the same way E has A and F, C. So if you can go to the next slide, please. So here the rule will say that if the preferred parent of the preferred parent, so in this case A for G, which is the preferred parent of its preferred parent, it is equal with the preferred parent of an alternative parent, then then G can consider this device as an alternative parent. So in this case, E fulfills this requirement because E and D, they have common ancestor, which is the common preferred parent. So in this case, we have the strict mode. I will quickly give you the other 2 examples. Next slide, please. So the next rule, which is a little bit more relaxed, it says that if the preferred parent of the preferred parent of node G is in the parent set PS of the potential alternative parent, then I may consider this node as an alternative parent. So in this case, between E and F, only E fulfills this condition, so E can be an alternative parent. And the last example I have here, it's called soft mode, which is the super relaxed mode, actually says that if there is any common intersection between the 2 parent sets of the preferred parent and of the potential alternative parent, this device can be candidate for alternative parent. So in this case, both E and F can be alternative parents. So these are the 3 examples, and in the next slide, I will just show you that there's a trade-off, like the more soft you go, of course you have higher probability to get an alternative parent, but you pay the cost. I don't have figures here, but we can show you over the mailing list that you pay the cost, which is the energy consumption, because you will traverse more nodes in the network because you are doing a certain level of flooding. So that's it for parallel functions and for this draft. In the next slide, I will have a short summary. So we have the parallel functions that is written in this draft. I do not have yet the alternative parent selection, and I would like to discuss in the mailing list or here. The next steps that I would like to discuss with you is to include more items that we are missing. So for instance, we are considering to add section about constructive interference in this document, as well as about packet reordering. And then I have a few questions that we can initiate the discussion about the feature of this draft. We have some volunteers to review the draft, or if somebody already draft, the position in the working group, and maybe the question will be whether this can be this draft, this work can be like the base, be transformed potentially as the architecture draft in this working group. Please, thank you.
Thanks for the presentation. Can we have a quick question from Lou?
I'll try to be real brief. Feel free to tell me that it's in the draft because I didn't read it. But what about this is specific to wireless? It seems that everything you've talked about could be applied to any DetNet. No.
I don't know. Do you think overhearing, is it possible in DetNet?
Repeat, what did you say? Overhearing?
The overhearing function can be applied in DetNet, in your opinion?
I think in DetNet you have a generic problem of resource contention that may not be visible at they may only be visible at the subnet layer, and then how to expose that, I think, is a generic problem.
Okay, Lou, it's Rick here, can I ask a follow-up question to your question? Do you want to take this work on in DetNet?
Don't know enough yet. I was asking as an individual contributor.
I understand that.
I mean, there are then a bunch of questions that we need to ask ourselves before, like, what about constructive interference? I mean, can we have such section in DetNet, or about constructive interference, because reordering we can do that in DetNet as well. So
this comes up with the sort of generic question of what's the layering model between the IP layer and the subnet layer, and what happens when there's behaviors at the subnet layer that can impact things at the IP layer. For example, if you have an interesting subnet topology, which could be wired or wireless, and going over one path takes away resources from another path, and how do we expose that in a layered architecture? The other option is an integrated architecture. I frankly think that that's a fundamental question for this working group, is for wireless, what type of architecture should be followed? But the questions you're asking, I think, are broader and can be answered for wireless as well, wired as well as wireless.
Okay.
Go ahead, Greg.
Probably just a need. So in the opening slide, you mentioned the reliability as a requirement. I think that without their acknowledgement, we cannot say that the solution provides the reliable transport. So what it improves the probability of delivering the packet.
Thank you for the question. I mean, it was just an option, only the actual destination to acknowledge this packet. We can do tricks at the MAC layer to have double acknowledgements. I mean, we have to play then at the MAC layer, right? So I think I was considering that we are in the layer 3. So I didn't want to go to the details of the layer 2 because it's really technology dependent to the layer 2, because we may need to have enough space at the time slot to have double acknowledgement, right? And to avoid ACK collision. So there are things that we need to discuss at the layer 2. So I'm not sure if we need to go there or not.
Okay. And just basically the question is then where the reliability is built in.
The reliability is built in by applying certain functions. Like if you do not have ARC at all, then you have less probability the packet will arrive at the destination, right? So you do ARC. Then, okay, let's say that ARC is not enough, then you do overhearing, which means that your neighbor, the second device, will listen to the same actual packet. Overhearing is not enough, you are doing replication. So the data packet that you send to the destination A, you will replicate destination B. So actually, you're doubling each time the opportunities the packet will go through the network.
So I'm going to jump in here because we're slightly behind time. I think my point, I think both of you are correct. I think your definition of reliability is different. One of you is talking about increasing the probability of reliable delivery, and the other is talking about guaranteed reliable delivery. But this is important discussion, so absolutely take this to the list. The other point I was going to make is I think this document is a really good example of interesting work that is not in the immediate charter, but if the working group thinks it's interesting, it could be adopted within this working group and worked on, and whether it ends up living in this working group or not is a secondary question. But it sounds like there's interest in this work, but the primary charter items for the working group are actually the use cases and understanding the problem space before we start proposing solutions to it. Anyway, we're on to the last slide, the last presentation, which is OAM.
Yeah.
Let me just try and move all the slides around. There you go.
Yep, it's me again. So this time to go back to the question of Lou, I'm not sure whether this document should be in RAW or .NET or in both. So this one, it's an open question for the moment. Or for me and for Fabrice, with whom we wrote together this document. So basically here we are having an overview of the features of OAM. Next slide, please. So again, RAW aims for predictable and available communication over potentially wireless links and potentially over fault-tolerant networks. Thus, we will need to tackle with certain challenges, which is that technology can be wireless. So wireless means we have limited bandwidth, and then we have to ask the question to ourselves, how much resources we are going to allocate for the control plane. Then we need to be proactive before the faults may occur. And finally, we always need to take into account, in order to be energy efficient, if we are having low power devices within the RAW network. Next slide, please. So I will present these three features. We have the operation, administration, and the maintenance. Next slide, please. So first we have operation, where the objective will be to keep the network up and running. So we have the connectivity verification. Basically means to test the connectivity continuously for a given flow or a circuit. Then we have the route tracing. Basically it means that in order to be predictable, the resources are reserved per flow. So we need to define some mechanisms for route tracing tools to be able to track the route for a specific flow. Then we have the fault verification and detection. So RAW again expects to operate over potentially fault-tolerant networks. Thus, we may need to define some mechanisms to detect such faults. To do so, we may collect, this is an example, to collect some large amount of statistics while the bandwidth is still there. So the network didn't change yet, or to apply some aggregated metrics to understand the cause of the problem. Next slide, please. We have the administration. So here the objective will be to keep track of the resources and how they are used. So basically we have a bunch of metrics to collect, such as packet losses or related with the link quality, like RSSI, LQI, or any other metric, or latency, both for end-to-end or locally buffering, delay. Then we have to focus on the granularity, which will depend on circuit or on device or on radio channel itself. Here, for example, if we observe that a certain radio do not behave well for a certain period, we may consider to blacklist this radio channel. And then we have to take into account these worst case metrics. So since RAW aims for real-time communication over potentially heterogeneous technologies, then we may prefer distribution over average values, meaning that the average values, they are not really representative. Okay, so we may need to have a detailed observation over the distributed values. Next slide, please. Finally, we have the maintenance. So here the objective is to facilitate potential upgrades and repairs. So we have the multipath for fault tolerance over independent paths. So this is the availability feature of RAW, RAW. We have the replication, elimination, or even the whole package of array of functions to decide when packets should be replicated, eliminated, or to be overheard along the path. Then we have the resource reservation, where we need to carefully reserve enough resources, even when the conditions in the network will change. And finally, we have this soft transition, or these soft reconfigurations in a raw network, where the raw network should stay or remain consistent when the infrastructure is reconfigured. So the new paths, when we have the new paths, are when we are allocating resources over the new paths, and we have to take care about the previous paths. So when the packets will start going through the new, and when they should stop going over the previous paths. Next slide, please. Here I have the discussion and the next steps. So if we are looking for volunteers, if any of you guys are expert in AOM, please, you are welcome to contribute, because me and Fabrice, we are networking guys, so we really need more guys, more people here to contribute and to give us ideas, because we will need potentially to include some items that we are missing so far. We would love to have some volunteers to review the draft. And again, the question is the same: the position within the working group, and if it is or not the time to be adopted in the working group. Thank you.
Thank you very much, Georgios. Anyone for the queue? Any questions? Nope. As mentioned before, the request for adoption we will take to the mailing list, so people have a chance to comment and think about it rather than handling it over WebEx. I have a question, actually, talking of working group adoption, for Niels and the DLR authors about the LDAX draft. It was unclear to me whether you were requesting working group adoption for that draft or not. I'm not sure if you're still here to have comment. I'll send you an email. Obviously, you're muted or have fallen asleep. Doesn't matter. So he says, looking at the time, we have some unstructured time for discussion. Oh, Niels is still here. Drop me an email or speak on the mic. It doesn't make any difference, Niels. If you let me know whether you're asking for working group adoption for that draft, please.
Okay, so we're not asking for working group adoption yet.
Okay. Okay. But are you asking for reviews?
Yes, please.
Okay. So we have 10 minutes, 11 minutes officially left on the session. This is our chance to throw open the mic for any open questions, and Taurus is joining the queue, I'm assuming. So Taurus, go for it.
Yeah, thank you very much. Very interesting presentations. Maybe high-level comment about the scope. So I'm a big fan of PROF, right? So don't get me wrong on that. I've been waiting for this to happen in the IETF, and that's what I find most exciting about DetNet. But when it comes to wireless, I'd be a little bit scared if we would try to constrain ourselves to considering the technologies which will help to basically create reliability and low latency, right? I mean, there are all type of research directions for age of information and other schemes that basically may not give you a deterministic behavior, but really very good probabilistic and application-aware low latency and reliability. And there's certainly a lot more that happens in the research space in that extent. And so I'm a little bit worried that we'd be just, trying to reuse old building blocks without looking what newer stuff is out there. Thank you.
well. It's quite quiet on Jabber. Nobody else is joining into the queue. So,
although I feel a little badly, I don't think I gave Florian a chance in the 5G queue because we ran so long.
Okay.
If there's still interest in asking that question, by all means, jump in. And I think, Lou, you had a comment on a question. So those are also open to the floor.
go ahead, Lou.
Sure, just trying to practice good queue control. So the comment I was going to make was first on the 5G is the first was in response to whether it belongs in the group. I think what certainly belongs in the group is trying to figure out that that integration model that I talked about earlier is the integrated versus layered model, and thinking about how information gets combined across these two different types of networks, for the wireless subnet and the general DetNet layer. I think that's a fundamental thing for this group to think about. Again, speaking as an individual. And to Tom, I didn't catch his last name's question of where he was aiming towards flow control. I think going back to the this layering model or integration model, there's two control loops you have to worry about. One is a slower control loop where you need information on how the subnetwork as a whole is behaving, so that at the DetNet layer you can make the right choices. And then at the DetNet wireless entry point, you also have to make good queuing choices. So you need sort of a quick response information of what's happening inside the subnet in order to perhaps back off, the equivalent of flow control in the data center. So I think you have those types of control loops that have to be looked at. And I know we're getting ahead of ourselves talking about solutions, but these are things that DLEP might be able to help with. That from Rick, from your working group, your other working group. Anyway, that's all I really have.
Thanks, Lou. Go ahead, Stuart.
So the thing I've never really properly got my head round with any of the solutions, but the one PROF, for example, in DetNet, or the things I think I heard here, is how you square the circle between guaranteed delivery and guaranteed latency, because I don't think it's possible to solve for both. All you can do is to increase the probability of not losing a packet a little bit. Clearly, if you wanted to be guaranteed delivery, you'd have to wait for an infinite number of retries. And so that doesn't work. And all the PROF things, type things do, is they give you another couple of attempts at getting the packet there, which is not about reliability. And it's not even about really guaranteed latency. It's sort of doing a bit better.
So Pascal has a response, Stuart. So go ahead, Pascal.
Yes, Stuart, I mean, you're obviously right. So other work we've been doing has been to provide a bounded latency and try to make the best delivery ratio within that bounded latency. And you can't be perfect. Even wires cannot be perfect. It's just number of how many nines you want to bring in the packet. So wireless will have less nines, but we are looking at all the possible ways to get more nines within, so better reliability within the bounded latency. You're obviously right. Does it make sense?
Yes, but what worries me is then, I don't think any of us have properly got our heads around how you set a number on any of that. I'm genuinely puzzled about, because I've worked on the PROS solution, as you know, as well. I'm genuinely puzzled about what expectations we're setting and what numbers we could write on a piece of paper to a customer, particularly if the customer is looking for a safety of life system.
Thomas, do you want to jump in? Do you?
Yeah. So, and to generalize the concern from my side, right? I think that when we looked at the DetNet things, right? These, very kind of 0% loss or something like that, and guaranteed 100% bounded latency, right? So I think it's very clear which subset of the use cases from DetNet and also the ones shown here that is really mandatory, right? But, a lot of people also in DetNet from their use case side said that, depending on what it is, a subset and, less strict requirements, higher probabilistic versions are equally fine for them, right? So that's an ongoing big, argument to have about these. And that's also one of the reasons why I'm saying that it would certainly help to make the results of this work here more applicable if we would be looking for, solution options that go beyond the pure deterministic model that DetNet is currently working on.
And this is Stuart again, and I guess you also have to remember that your benchmark is just multiplying the bandwidth by quite a lot and see whether that's good enough.
I think I can spot a fantastic mailing list discussion starting there. Can I suggest that one's taken to the mailing list? Janos, do you want the last word? And then I think.
Well, sorry, I wanted to ask Stuart if he's only puzzled because of bringing wireless into the picture, or puzzled for pre-off for wireline as well. That was not clear to me.
So definitely a mailing list.
Yeah, sure. Thanks. Sorry.
Thanks, guys. So, Eve, I think we have. It's very difficult not being able to see your co-chair.
I've been sitting here quietly. You've been doing great.
I've spoken for hours. It's your turn.
No, I think we've reached the end of the session, and thank you to everybody for the presentations and the great questions. We have plenty to talk about on the mailing list, and so we probably need to get a little bit organized about drafts. But I think there's plenty of questions also about mission and some gaps, especially regarding this last bit of conversation about how do you both specify what quality of service looks like, whether it's determinism or something broader, and how do you do joint optimization among things that are competing requirements. So I think there's fodder for some really good discussion. Thank you, everybody, for hanging around in this WebEx session, for showing up, as well as staying awake in time zones that are not that, this wasn't such an ideal setting. And thank you to folks who managed, and mostly Pascal and others who typed into the Etherpad. Greatly appreciated.
And Blue Sheets, if there was a slight kerfuffle to do with some names may or may not have disappeared from the Blue Sheet, we're going to do a little bit of post-mortem to find out where they've gone. Can you please check that your names are on the Blue Sheet section of the Etherpad, please?
And I would also say that if people had some comments in the chat window that they wanted represented in the minutes, please do go to the Etherpad to see if they got captured. Okay.
Good point. Oh yes, and thank you to Ethan for happily typing in Etherpad, as well as Pascal for taking minutes.
So the last time I looked, you were about 30 names short.
Oh,
because you can see from the WebEx that there were 70 plus participants.
Okay, well, thank you for catching that number before people started disappearing. We'll report that. And maybe the recording will help us as well. We'll see.
We'll see what we can do. Thank you. Yeah.
Recording should have the names in it. Maybe you folks need to type them down, though.
Yeah, they won't have the affiliations, though, will they?
They won't have the affiliations.
And some of them are acronyms as well, which is always fun.
Okay, well, we'll do a broad request to the mailing list as well.
Okay, so I think we now declare this session closed. Thank you very much. Comments to the list, please.
Thank you.
And thank you for taking part. Is that right, Eve?
Yeah.
I think we're done. I think we're done.
We're done.
Okay.
Call it a wrap, as they say in Hollywood.
Yep, right. I'm unsharing my screen and pressing mute. Goodbye.
Bye-bye.